Well, welcome to PBS at Sac State. That's the Precast Bridge Studio. My name's Eric Matsumoto, Professor of Structural Engineering, and I'd like to share with you briefly to let you know what we did at Sac State to transition online during the spring 2020 semester. Let me share with you a few slides and walk you through this with the help of a couple of my students. You can see here kind of an introductory slide of some of the students that are excited to be part of our program. Now, when we encountered the sudden coronavirus crisis, it was our project Precast, a challenging problem that we had to solve quickly and come up with a reasonable solution. Wasn't that easy? Many universities had to do exactly the same thing. At Sac State, we remembered who we are and the motto of our program. Despite the stressful situation, we remembered, don't be stressed, be precast, pre-stressed. Now, in that spirit, we also remembered what Jim Voss always said. No matter what happens, we still need to give precast a seat at the table. So, we adopted our governing principle, which was to move online quickly, but don't unnecessarily compromise the quality of our program that exposes students to precast pre-stressed concrete. And the approach was threefold. Number one, we kept our precast module in my reinforced concrete design class. That means we continue to expose the students to the fundamentals of precast pre-stressed concrete. In addition, one of the highlights of such a class are the class projects. And we had 4 of them that included precast pre-stressed concrete, yet because we needed to go 100% online, we had to modify some of the projects as we will briefly describe. And finally, our secret weapon here at Sac State is our PCI student club. And so we kept students in the student body engaged and exposed to precast pre-stress through the club activities. Now in lecture, you can see on the left-hand side, students were kept engaged during lecture. Despite the challenging course content, we still made sure they were learning pre-stressed components and how things work from a technical perspective. And using, of course, online videos and approaches like this, we still could expose them to fabrication, of course, plant tours, understanding the building blocks of precast concrete and bringing it all together in a structure like the one you can see at the bottom here, which is Parking Structure 5, an award-winning structure at Sac State. Now, the projects are the highlight experience of the students during the semester, and so we did our best to not compromise that. It was interesting because one of the keys to such challenging projects we have for our students is the industry interaction. Because we couldn't bring these industry experts to campus, we still connected with them, i.e. the students connected with them online via Zoom. And so you can see here one of the projects was a precast canopy structure. It's to be a signature structure in our engineering quad, currently under design by the students under the mentorship of JVI, Chuck Magnesio and Heidi, as well as Clark Pacific, a local precaster around the corner, and Glenn Underwood and Doug Bevere were crucial there. Now we had 2 teams conducting this project. They were combined teams involving 2 grad students with about 4 to 6 undergrads on the team. And you can see from these slides from the second team called Got Canopy, some of the aesthetics related to the project, as well as different precast members and incorporating the JVI connections. And at the bottom corner, you can see Doug Bevere actively engaged with this 8-person team working together to come up with a solution. The final project is Parking Structure 5. And this is an award-winning structure I mentioned on our campus. And it's a very challenging project that addresses for the students, not only the construction sequence, but the design of the gravity system using double T's, looking at connections like the Casale hanger, as well as representative seismic calcs, very challenging calculations to look at the precast hybrid moment frame behavior and design characteristics. So students, after completing their design, made formal technical presentations, and therefore transitioning online was still very, very much possible in this kind of project. However, our fourth project was a PCI Big Beam. You can imagine, since that is a design, fabricate, and test project, it had to be impacted because now students were limited in anything that involves students being together in person or at a precast plant. Now, this is the award-winning team from the prior year that was the starting point for this year's team. So at this point, I'm going to turn it over to Jacob Eiton and Madison Schell, who are going to talk to you firstly about the Big Beam project, as well as the PCI student chapter activities that were involved during the online transition last semester. Jacob?
Thank you, Dr. Matsumoto. Hi, everyone. My name is Jacob Eiton, and I had the privilege of participating on this year's Big Beam team. This year's team was very excited as it was the first time at Sacramento State, which both undergraduate and graduate students have collaborated for the competition. Unfortunately, early progress was hindered by the onset of the coronavirus. With the stay-at-home order and competition canceled, it became apparent that we were no longer going to be able to fabricate the beam. However, a precast project was required for both the undergrad and grad level reinforced concrete design classes. So as a team, we were more than prepared to see the project through. To assure the fabrication process wasn't completely overlooked, as a team, we reached out to both Clark Pacific and previous Sacramento State teams for video footage of previous beam fabrications. We wanted to ensure that students were still able to gain an understanding of the materials and overall production process. More importantly, because the beam was no longer going to be fabricated and tested, we were able to use this time to further analyze the design of the beam. The initial design of our beam shared similarities to that of last year's Sacramento State team. Once fabricated and tested, this design experienced shear failure prematurely. A post-investigation found that the spacing of the welded wire used for the transverse reinforcement had been placed at a greater distance during the fabrication process than that which the design had accounted for. So as a precaution, this year's team decided to tighten the spacing of the transverse reinforcement to avoid a similar reoccurrence and ensure that if fabricated, the beam would fail in flexure. Ultimately, we believe we were able to design a beam which met the competition guidelines and hopefully will be a good reference for future Sacramento State teams. As Dr. Matsumoto mentioned, the PCI student chapter has had a great presence here on campus at Sacramento State. And as the pandemic was unfolding, the outgoing officers did an incredible job transitioning from in-person to virtual meetings and even hosting an election. For the virtual election, we actually had a record number of students all vying for officer positions. And in the end, the members elected the next wave of officers and Madison Schell as the new president. So with that being said, Madison, I'll let you take it away. Thank you.
Thanks, Jacob. Transitioning online definitely had its challenges, but despite those challenges, we still managed to host 2 general meetings and maximize engagement amongst our student members using Zoom. During the first virtual meeting, Mark Thomas, project manager, Jason Hickey, provided a fascinating technical talk on the design and construction of the Green Valley Overcrossing. This overcrossing is the second longest precast girder bridge in California. Additionally, attendees got to hear from fellow students who attended the National PCI Convention in Fort Worth, Texas. We ended the semester with an incredible final event, which included lectures from 3 industry professionals. Ruth Lehman, the executive director of PCI West, has been instrumental to the success of our student chapter, and she kicked off the night by educating our members on precast hollow core planks. Wes Sennett, a senior bridge engineer at MGE Engineering, followed this lecture showing students some of the challenges designers are facing in the California high-speed rail project. And last, Austin Young, a Caltrans bridge engineer, provided insight into the construction process once Precast members arrive on site. We ended the night by bidding farewell to our outgoing officers and introducing our new officers, which together forms the largest leadership group that this club has experienced. This fall, we will not be able to meet in person, but still we remain enthusiastic and are taking full advantage of virtual meetings and are lining up experts from across the country to address our students and to continue to increase engagement and interest in the PCI student chapter. Thank you.
Thank you, Jacob and Madison, for that summary of the online transition and your experience in it. And I want to conclude by saying that this coming fall, we have a lot of things planned for the students in our PBS class, which is a 3-unit precast pre-stress class that integrates CE and CM students together. As you can see in this picture, we've been developing it further and further, and we already have some field trips that have been arranged with special safety measures to be taken. And in addition, we'll have our many club activities. As you saw last semester, we continued with those this fall. We will continue and even grow them further in an online, safe manner. So that's PBS at Sac State. Thank you for listening.